We are looking at type D questions in 2013 physics. The first question is number 46. You have to calculate the energy of the third level of an atom if the ground state energy is minus 24.8 electron volts. Alright, that's the third level energy. Okay, to solve this problem now, we have to look at formula that relate energy levels and the associated energy. Normally we use E1 to represent ground state, E2 to represent second energy level, E3 to represent third energy level, and so on. Where this is what N1, this is N2, this is N3. So that means we have E1, En. So that is denoting the energy levels. So where N is the level and the energy at that level is E. Now the relationship is given us that if we have E1, we want to say the energy of a level 1, right, and the level 1 itself, square of it, will equal to the energy of level 2, and the level 2, the square of level 2 is itself, and also equal to that of level 3, then the square of the level. Okay, so that is the formula. So from that, we can easily say that E1 N1 square can be equal to E3 N3 square. Okay, so if we have that formula, we can bring it out to answer the question that we have. Now, that question, to answer that question, we use the formula in square, that's in box. Now, we have that the energy at the ground state, which is E1, that means we have that E1 is equal to minus 24.8 electron volts. Okay, and then that's the energy of the ground state. We are asked to calculate the energy of the third level. Now, so you applying this formula strictly, that means E1, which is minus 24.8 electron volts, times 1 square, because the energy level is first energy level, which is ground state, that will be equal to third energy level 3. That's the energy level. What's the energy of that level? That's E3, then times the square of the level. The level is 3, so we square that. That's third level. So that is 3. This first level, which is 1. Now, from that, we can easily get our E3. So therefore, E3 will equal to minus 24.8 electron volts all over 9. Okay, what does that give us? So divide all through, we are going to have, okay, let's do that. Minus 24.8 divided by 3, we have approximately minus 2.75 electron volt. Okay, so that is option C. Option C is the correct option to that question. Okay, all right, please don't forget that formula. The formula again is, we are relating energy level with the energy of that same level. If we have level 1, okay, that's energy of level 1, then times the square of the level. We go to energy in the level 2 times the square of that level, and that will still be equal to energy of level 3 times the square of that level. So when you relate this, you solve a problem of that nature. Now, number 2. The number 2 question that we have is that in photo emission, the number of photoelectrons ejected per second depends on what? Okay, we have option A. They say which of these determines the number of photoelectrons ejected? By the way, that's photoelectric effect. Photoelectric effect. What do you mean by photoelectric effect? That's the emission of electrons from the surface of a metal by what? By light that possesses sufficient energy. Alright, sufficient energy means sufficient frequency, and that frequency must be above the threshold frequency. Must be above the threshold frequency, or we say the energy must be above the work function, the binding energy of that electron. The energy that binds that electron to the surface must be exceeded before the electron can be liberated from the surface of a metal, and that effect is called photoelectric effect. Okay. Now the correct answer to this question is what? D, option D, which is intensity of the beam. It's only intensity of the beam that can increase the number of photoelectrons. Threshold frequency of the metal, that does not affect the number of electrons. Threshold frequency of the metal determines the work function, right? Threshold frequency of the metal determines the work function of the metal, right? Then, so B, that is the work function of the metal. Now, frequency of the beam, yes. Frequency of that light can only determine the maximum kinetic energy of the electrons. Alright? It will determine the maximum kinetic energy of the electrons. It cannot determine the number of photoelectrons ejected. So the number of electrons ejected will be determined by the intensity of the beam. Then number 48 said the particle nature of light is demonstrated by the correct option there is option A, which is photoelectric effect. Photoelectric effect is what demonstrates that light has particle nature. Okay. The number D there, which is diffraction of light, that one is demonstrating wave nature. All right. So the correct option is option A, which is what? Photoelectric effect. All right. Another effect that can still demonstrate the particle nature of light is Compton effect. Compton effect. Okay. Now the last question, which is number 49, say the energy of a photon having a wavelength of 10 to the power minus 10 meter is what? Okay, we want to calculate the energy. By the way, photonic energy is given by, that the energy of a light, of a beam, is given by HF, right? Where H is the Planck constant and F is the frequency of the radiation. So we know from wave theory that frequency is speed over lambda, right? So that means energy therefore is hv over lambda. Okay. Now we have been given, this is a Planck constant which has been given as 6.63 times 10 to the power what? Times 10 to the power minus 34 joule second. Then what is the speed? The speed is 3 times 10 raised to the power 8. Okay. Then divide through by the wavelength, which is 10 to the power minus 10. Right. Now, if we work that out carefully using appropriate indices, we're going to have 6.63 times 3 times 10 to the power minus 34 plus 8 plus 10. Now, that's following the rule of indices, and we're going to have, when we solve that carefully, we're going to have 1.99 times 10 to the power minus 15 joule. Okay? By approximation, that's going to be what? 2 times 10 to the power minus 15 joule. Right. So that's the energy of that radiation. Okay? Check out the workings again and just see what we did. You know, we used the formula that says energy of a radiation is Planck constant times the frequency of the radiation. Then we get the frequency from wave theory, which is V is equal to F lambda, wave equation. And from here we know that making F the subject of the formula, we have F therefore as what? Speed over lambda. Alright, where the speed of light is normally denoted as C, which is 3 times 10 to the power 8 meter per second. Alright, thank you very much. I hope you enjoyed this tutorial. Okay, I'd like to invite you to watch other of my videos on solutions to several to other year questions. Okay, you please visit my blog, right, for more videos. Okay, that may be of good, help to you in your preparation for your exam. Right, that's my blog. Thank you very much. I wish you all the best.